So the traditional optical magnifiers get up to about 4x power in magnification, but some people need more than 4x magnification for their component part inspection. And sometimes that magnification might be 7x or 10x or 20x and above. Well, you're not going to be able to do that optically with a general magnifier unless you go to a microscope. But the problem with microscopes from a standpoint of people who are working with them hours upon hours each day, when they're positioning their body over a binocular microscope and hunching over that microscope, it's very difficult for them to use. So with digital magnification, digital cameras, and digital technology, we can perform inspection tasks in a much more ergonomic way that's easy for the user. So a progression out of the optical power or optical magnification power into digital, this particular system is also mounted conveniently on the Dazor floating arm, but it's an HDMI camera, and we have a series of different optical lenses you can choose from based on the level of magnification and the field of view that you desire for your application. And then the user can use this for inspection. And with this particular camera, it has a very high frame rate, so there's no latency between the actual movement of the component part and how it displays on the monitor itself. So it's frustrating for the operator when they're trying to pick up a part and maneuver it when there's a delay in the actual imaging that's taken place. But it doesn't matter whether it's a circuit board for inspection. It could be inspecting wire crimping, which is critical in harness assemblies and cable assemblies, to make sure that the crimp is good, make sure that all the connections are good. It could be a mechanical component part that's being inspected for burrs, as an example, or just to make sure that dimensionally it's correct. But what we found is that the majority of application where there's multiple operators needing to perform an inspection task, they don't want all of the additional technology like interfacing it with a computer, because it will slow down the operator in what they're doing. So the whole objective is to offer a cost-efficient digital solution that meets the field of view and magnification requirements for the particular task at hand, while also allowing the user to be efficient in what they're doing. So low cost, efficiency, get the job done, ergonomically better for the operator than using a microscope, but an extension of the traditional optical task magnifier. This particular system is designed for simplicity, to get the job done with the power of magnification that's necessary. And there's different optical lenses that we offer that can meet whatever requirement that they have in terms of magnification range, but it keeps it simple at a lower price point, so you can buy multiple systems. You don't have to buy one or two systems, for an engineering analysis or an engineering lab, as an example. This should be used in an operating environment where operators have to do inspection, where they would have historically used a 7x, 8x, 10x, 15x, maybe 20x microscope. One of the other benefits of this particular system is that you do have a nice working distance between the bottom of the lens and the object that you're looking at, which of course you don't have with a microscope. That working distance can be very small. So you can actually get a soldering iron, as an example, underneath here. And you can change the field of view by raising, and then there's just a very simple aperture adjustment for lighting, and there's also a focus adjustment. So you can change the level of magnification and the working distance, and then you have a simple focus adjustment here, just depending on what your particular need is. The system that we have here has a very fast lens on it, So we're just using ambient light in this environment. There's no supplemental or secondary lighting that's actually used here, which is nice because if you're working with an object that is reflective and you have secondary supplemental light shining down, glare is always an issue. That glare bounces off of the object and goes back into the sensor and causes hot spots. But since the lens is very fast and we have no secondary lighting, I mean, I can actually wash this out completely just by controlling the aperture on the lens. So we can simply use auxiliary lighting that's already in the work area without having to have any supplemental or secondary lighting. And then if I want to zoom in on a particular area, I simply lower the camera, open up the aperture, and then focus in. And then I'm hands-free to do the work that I want to do. With regard to the articulating arm, this arm is comparable to the arm that we use on our task lighting and other illuminated magnifiers. It does come in different lengths depending on the depth of your workbench, as an example. So we have a shorter arm or a longer arm. The other thing too that's important to mention, as you increase in magnification power, you can introduce vibration into the actual field of view of the object. So when we get up to about 20x magnification and higher, we have a microscope boom option where we actually have a mounting configuration for the camera and optic that mounts to a heavy weighted boom, and then that base of the microscope boom isolates vibration and doesn't introduce it into the screen that the operator is looking at. So as you increase in magnification power, the sensor is just more sensitive to vibration, and so we isolate that through a different mounting option altogether. So with this particular system, we do have the standard lensing options and mounting configurations, but we also recognize that there are unique work environments that may require either mounting or alternative lensing options, and that's what we do. So we can also customize, in addition to offering the standard product line, we can also design and customize tailored solutions to particular applications for the end user.